Okay, so again, we got a rhombus, 4 congruent sides. Two other properties, though, in addition to parallelograms. One, not only do the diagonals bisect each other, the diagonals are actually perpendicular. Now, what does that mean if they're perpendicular? They form a right angle where they intersect. So that means that right there is a right angle. Okay? In fact, all 4 angles around there would be right angles, right? Okay. The other one is, not only do the diagonals bisect each other, they actually bisect all of the corner angles. So this angle right there is half of the big angle. So that means these 2 angles right there would be congruent to each other. Now remember, opposite angles are congruent, so these would also be congruent to those. Right? And then the top and bottom would be congruent, right? But the idea here is the angles, the diagonals bisect this angle. So if this angle was 72 degrees, one of them would be 36 degrees, half of that, okay? And if I know the top angle here is, if I know this angle right here, let's say I know that's 37, then the other one would be 37. And the whole angle there would be 74. Right? And so that means this angle would be 74. And these two have to add up to 180, so this would be 106, and blah, blah, blah. We can continue finding everything else. Okay. So let's do a couple examples with rhombi. I was going to say rhombuses, but it's rhombi, I guess. So it says the measure of angle DEC. So find angle DEC on your picture and mark it with an arc of some sort. Arc meaning the little curve or something. So DEC would be right there. Agreed? Now that angle is formed by the intersecting diagonals. So what do we know about that angle?
It's 90 degrees.
We know it's not just any angle, it's a right angle. So we can actually change our little arc to a little square. So DEC is a right angle, which means it's, as Robert said, what exact measure? 90. But we're also told that it's 4x plus 10. Okay, so we have two different appearing values for the same thing. So we set them equal to each other and solve the equation. I don't have one. So we have 4x plus 10 equals 90. Okay, this is how we set up the equation. We figure out two things that represent the same thing, set them equal to each other, plus you, and now we use some algebra. So subtract 10 on both sides. So we have 4x on the left, 80 on the right. How do we solve for x?
Divide by 4.
Okay. So 4 times what is 80 divided by 4? X must be 20. Next picture says the measure of angle PTR is 140. So find angle PTR and put an arc on there. And so PTR. So we'd have this arc right there. Now if that angle is 140 degrees, what is that also giving us measures for?
The 2 angles are 70 degrees each.
So these must each be 70, right? That's useful information, possibly. Not necessarily, but possibly. It says find RPQ. So find RPQ. So we're actually looking for this angle measure up there. So does knowing that each of these are 70 really help us find RPQ?
Yes. No.
I don't think they're vertical angles. They're not like right across from an intersection. Yeah, they're different sizes. So knowing these are each 70, not necessarily helpful in this case. Excuse me. So what is the relationship though between this angle and these two? There's got to be something here. Yeah, what do you say, Robert?
Right in.
Right triangle. Someone said 180.
Okay, so angle T, so the whole angle, and P are supplementary. Why? How do we know that? Good. So they are, we call them consecutive, right? Now, angle T is what measure? 140, right? Really, I could say PTR plus blah blah blah, but I'm just going to use the vertices. So angle T is 140, right? Plus angle P equals 180. So what does the whole angle P have to be?
40.
Okay, so subtract 140, so angle P is 40. So this whole angle is 40, right? But the diagonal bisects that angle by this definition up here. And so this little green angle I have marked right here must be 20. So measure of angle RPQ is half of angle P, which would just be 20 degrees. Ah, it's a 20. Okay. Here our last quadrilateral for right now is a square. Okay. What's up? PTR, we were told was 140. How do we find RPQ? Well, angle T, so this angle right here and this angle are consecutive angles. So they have to add up to 180. Okay, so we know angle T, which is also known as PTR, is 140. So this has to be 40. So this angle up here in this corner, this whole thing has to be 40. But RPQ is half of that. Okay?
I love math.
All right. Last figure, a square. So a square, again, is a parallelogram. And a square is the love child of a rhombus and a rectangle. Okay? It inherits all of the properties of rhombi and rectangles. Okay, so what makes a rhombus special? What makes a rhombus as opposed to just any other parallelogram? No, parallelograms can be tilted. Just regular parallelograms. Okay. So rhombuses, the important thing is all four sides are congruent. Okay? Now, what makes a rectangle special in terms of other parallelograms? What makes a rectangle stand out?
All the angles are 90.
All the angles are 90. So if we take the idea that a rhombus has all four congruent sides, and the fact that all four angles are right angles, we suddenly get a square. Okay, so you put a rhombus and a rectangle, those two things together, we get a square. Okay? Now, just like a rectangle, the diagonals are congruent. Okay, so that's the property of a rectangle. Just like a rhombus, the diagonals intersect at what angle? 90. So we can put these concepts together to find some information. Look at example 3. In the square shown, find x and the measure of angle EDR. So two questions in one picture here. So which angle is labeled here? So NMD. What do we know about NMD? It's 5x plus 10, but what else is it?
It's right.
It's a right angle. So we can write an equation. We have two things that represent the same thing, two quantities that represent the same thing. So 5x plus 10 equals 90. So we subtract 10 on both sides. We get 5x equals 80. Divide by 5. Now think of it like this. So 20 times 5 would be 100, right? So we take 20 off of that. So let's take off 4 and we get 16.
I did that except I did it with 12.
Yep. But you start off with something that you know, and then you go from there. Okay, and then it says find angle EDR. So EDR would be this angle right here. Okay. Now what are the four angles, the corners of a square? What's each one's measure?
90 degrees.
90. What do the diagonals do to these corner angles in rhombi? They bisect it. So what's the measure of angle EDR? So look at EDR, which is this guy right here. How much of the 90 is it?
45.
It's 45. Okay. Very good. Okay. Okay.
Love that.
All right.
Wait,
Yo.
Does that mean that every like little half angle, because it's angle like bisecting me, does that mean every like angle's gonna be 45 degrees every like second?
In what specific quadrilateral? A square. In every square, if you have a diagonal drawn, it'll be bisecting, that'll be 45. Every square. Notice in rectangles, though, that didn't happen. Remember that on Friday? You weren't happy about it? The rectangles don't work that way, right? So it works with squares, doesn't work with rectangles. Finally, in the square shown in example 3, so same picture. And by the way, on your quiz tomorrow, you'll have one picture drawn. It'll be 4 different questions with that one picture. So we can't take any answers from this and apply it over here. It's a completely different question, just the same picture. It says in the figure shown below, or right there, find ND if RE is 24. So where is ND? Well, it's this side right here, right? And RE would be this side. Now, what do we know about these two sides? What's the relationship? They're congruent. How do you know? It's a square, so all 4 sides are equal. It's a parallelogram, so opposite sides are equal, right? There's all kinds of reasons. So if RE is 24, then what's ND?
24.
Okay, so RE is equal to ND.
How do you construct a square?
Great question.
It's in the box.
And what's it say?
See in depth.
There you go.
But I don't want to. I don't want to go to topic E.
Okay. In-depth topic E.
Where is?
I know there isn't.
It's not on this page. You'd have to see a separate page. What is the measure of angle EMR? So look at EMR. What do we know about EMR?
It's a right angle.
It's a right angle. So the measure of angle EMR would be what? Okay. All right. So there are something like 17 questions, but they're fairly short questions, all dealing with rhombi and squares. So we're finishing this up today. Tomorrow, I said this last part out. I was wrong. Tomorrow we're going to go over trapezoids and their properties. Wednesday will be a review, and Thursday will be your test over quadrilaterals.
It's a test, not a quiz.
The test. The quiz will be tomorrow, specifically over rectangles and parallelograms. The 5 questions. Yes, test already. Other questions at this point? Dealing with this?
Yes.
Okay.
Okay. So can't you call a rhombi diamonds too? Because they're basically diamonds.
Diamonds are
You can
rhombi.
call them whatever you want, sure. But I would say a diamond is usually represented as a rhombus. In other words, you could represent a diamond as a parallelogram if you wanted to, if it's elongated. Right? But usually the figure that's used like on a card is, I don't know if that's a rhombus or not, to be honest. Like on a playing card, I would say that's probably a parallelogram. I don't think the sides are congruent. But I'm not sure. To be perfectly honest. I really don't know. So, I mean, let's see here. Well, you know what, actually, Weston, let's tilt your paper, like down here. And yeah, I guess that's probably like a diamond, right? For sure. But the geometric term is rhombus.